Hey everyone, I'm Ayub, Solutions Architect at CAST Software. As a developer, you've asked yourself, what else breaks if I touch this class, and how do I make sure my tests cover it? You ask your AI assistant, but it's stochastic, it guesses, you can't trust it. Today, I will show you how CAST Imaging maps your application and how its MCP server feeds your AI with what it's been missing, architectural context, turning stochastic answers into deterministic ones. So let's start in CAST imaging. Think of it as an MRI scanner for your source code. It parses every file, class, method to build a precise blueprint of your application. I'm going to focus on this Java class right there, product price tag coming from the e-commerce application. So there is one unique color above a JSP page, product slider, and a white fan of callees below, exactly 16. We have first tag support, big decimal, etc. So every single object you see here is potentially affected if you modify product price tag and you don't know it as a developer without imaging. You don't want to change something if you don't fully understand how deep it goes in your application. And that's your impact analysis right there. So this software intelligence lives inside CAST Imaging Viewer, but there is a way to access it from your IDE. So let's bring it where you actually work as a developer, VS Code. So CAST Imaging exposes its data through an MCP server. It's kind of a bridge that gives your AI assistant the context it's missing. Let's use Claude in GitHub Copilot here. We'll give it the same question, but one without using the MCP server, the first one, and the other with it. So I asked Claude to list all the dependencies of the product price tag class grouped into colors and callees and provide a count for each. And as you can see, dependencies are missing. We only have 11 callees. The answer proves that the probabilistic nature of AI. And as a developer, you simply cannot trust this to make safe changes. So now let's give it the same prompt, but with the MCP feeding Claude. As you can see, we have one color, the right one, and 16 callees, exactly what we saw in imaging. That's because the AI has been fed with exactly what was missing, the architectural context, so no more guesswork. So now you know what's at risk. You should think ahead. Test the right code, the object itself, product price tag, its first color, and callee, for example. And I asked Claude in Copilot to use the MCP server for that class to generate unit and integration tests validating the core logic when we will change the dependencies. And I already generated them successfully. And you see now that imaging context enables high coverage, highly relevant tests on the right object before you ship. To conclude, CAST Imaging scans your code, builds the map, the MCP server feeds that map into your AI assistant, so you can get the impact analysis and test generation you can actually trust directly in your IDE. You can say that AI can write code, but with CAST, it finally understands your system.